Hello everyone, this is Kajal Bagil. Today we are going to learn about memory mapping. So these are the following topics which we are going to learn today. So we are going to learn about memory hierarchy. So memory hierarchy refers to the arrangement of different types of memory storage in a computer system based on excess of speed and capacity. At the top of memory hierarchy, there are registers, which are fastest but have the smallest capacity. Following it, there is cache, main memory, and local storage. Learning about memory organization. So first, we learn about what is memory organization. Memory organization refers how data is stored and accessed within a computer system. So there are two ways. First, simultaneous access memory organization. Second, hierarchical access memory organization. Simultaneous access memory organization. In this, CPU interact with multiple memory levels at same times and gets the data. This is also known as parallel memory organization. Hierarchical access memory organization. Hierarchical memory organization. In this system, CPU can interact with only one level at a time. So this is the arrangement for simultaneous access memory organization, and this is the arrangement for hierarchical access memory organization. As we know, in simultaneous memory organization, CPU can parallelly access both the levels. So hit ratio for finding any element in memory can be expressed as H1 into T1, that is finding an element in level 1, plus 1 minus H1 into T2, that is finding of element in level 2. Similarly, we can go for level 3. In hierarchical memory organization, CPU first access level 1, then level 1 will access level 2. If we don't find any element in level 1, then level 1 will find that element in level 2, and then that element will goes to level 1, and that then goes to CPU. So, hit ratio for finding any element in hierarchical memory organization can be expressed as H1 into T1 plus 1 minus H1 into T1 plus T2, time taken by both the levels. Similarly, we can define an expression for three-level memory organization. So next we are learning about cache mapping. Cache mapping is a technique that is used to bring main memory content to cache, which means that as we know, main memory stores all the data of the computer. So if CPU wants any data, then it need to be bring from main memory to cache memory. So bringing of that data from main memory to cache memory is defined by cache mapping. There are three techniques of this. First is direct mapping, second is associative mapping, and third is set associative mapping. Moving on to direct mapping, as the name suggests, direct. So, data from main memory is directly bring into cache memory by using a formula which is k mod n, where k is address of main memory block, mod is total number of lines in a cache. This means that there is specific location for every data in cache memory. Each location in cache holds the data at a specific address in the cache. In direct mapping, physical address. So as we know, for every data there is a physical address which CPU generates. So for every physical address, indirect mapping is divided into three parts, that is stack, bits, cache line number, and byte offset, or we can say this as block offset. So this is number of blocks basically. Further moving on to Fourier associative mapping, we use Fourier associative mapping to overcome the drawback of direct mapping. In direct mapping, even if there is an empty line, we don't fill it with any memory block from main memory because we use a specific formula k modulus n, which specify every block in main memory to every block in cache. So, in associative mapping, we don't use any such formulas. Every block from main memory is accessible to every line in cache until and unless it is not filled with any other data, which simply means that if there is an empty line in cache, block from main memory can be filled into it. Set associative mapping. Set associative mapping is a combination of direct mapping and fully associative mapping. In this, cache is divided into number of sets. Blocks from main memory are directly shifted to these sets based on the basis of a formula which is A mod n. In this, A is a block from main memory and n is number of sets. Thank you for watching this video.